Okay, problem number 42. Let's find absolute maximums of this function on the closed triangular plate bounded by the lines. Let's graph this here. So x is equal to 0, and y is equal to 8, and y is equal to x. And so intersect at a point 8, 8. This is 0, 8, and this is 0, 0. So this is a continuous function on a closed bounded region. It's guaranteed to take on global min and global max, absolute min and absolute max values here. How do we do this? We're going to find critical points for the inside and then check the boundary. Critical points for the inside, let's see, f sub x and f sub y is what we have to compute here. The x partial derivative is going to be 2x minus y. The y partial derivative is going to be negative x plus 2y minus 6. And we want to set both of these equal to 0 and solve. Let's see here. This first equation tells us y has to equal 2x. And then if y is equal to 2x, we can substitute that into the second equation to get negative x plus 2 times 2x minus 6 is equal to 0. This is 4x minus x is 3x minus 6 is equal to 0. X is equal to 2. And y is equal to twice that. Y is equal to 4. So our critical point is at 2, 4. And yes, it does fall in the interior. It does fall in the interior of a triangle here, so that's one place that we're going to have to check. Okay, so let's just start making a list here of our points we need to check. 2, 4. Okay, so now we have to check the boundary, and this is a triangle, so we're going to have to check this in 1, 2, 3 different chunks. And so the first chunk is, let's do this chunk right here. This is the line segment x is equal to 0. X is equal to 0, y runs from 0 to 8. So plugging x is equal to 0 into our f of x, y, we have, I'll just call it g of y is 0 squared minus 0 times y plus y squared minus 6y. And now we just have to do calc 1 problem, max and minimize this on this interval here from 0 to 8. So the critical point g prime of y, this is just a one variable derivative, so I can just use prime right here, is 2y minus 6, and we want this to equal 0. So this is true when y is equal to 3, and of course we had x is equal to 0. So the point 0, 3 gets added to our list. Also, we should know to check the endpoints here. Where do mins and maxes occur, either at critical points or at the endpoints. The endpoints here would correspond to 0, 0, and 0, 8. So let's go ahead and add 0, 0, and 0, 8 to our list of points that we have to check. Okay, next up, let's do this chunk right here. This is y is equal to 8. X runs from 0 to 8. And so plopping in y is equal to 8 into our f of x, y. So h of x is going to be, let's see here, x squared is, still x squared minus 8x plus y squared is 64. 8 squared minus 6 times y is minus 6 times 8 is negative 48. So this is x squared minus 8x plus 16. Okay, so again, take the derivative, set it equal to 0. 2x minus 8 is equal to 0. So x is equal to 4, y is equal to 8. So the critical point here will be 4 comma 8 right about there. And then again, we need to check the endpoints here of this interval. So 0, 8 is already written down. We just have to add 8, 8 to the list. And then finally, we need to check this side here. We need to check this side. This is the line y is equal to x. So let me say j of x. Replace x with y here. Sorry, replace y with x. So we're going to have x squared minus x times y is minus x times x minus x squared, plus y squared is x squared minus 6 times x. So this just, those cancel, x squared minus 6x. And so then j prime of x is 2x minus 6, x is 3, y is equal to x, y is 3. So our final critical point that we have to check is 3, 3. So at this point, it's nothing more than just plugging in these 7 points into our original function f of x, y, and picking the biggest and picking the smallest. So if we plug in 0, 0, f of 0, 0 is equal to 0. If we plug in x is 0 and y is 3, f of 0 comma 3 is going to be 0 minus 0 plus 9 minus 18 is negative 9. And we plug in y is, x is 0, y is 8. We get 0 minus 0 plus 64 minus 48 is going to be 16. And we plug in x and y are both 3. We get 9 minus 9 plus 9 minus 18. So that's again negative 9. Let's see if we plug in x and y are both 8 in here. This will cancel and we'll again get 64 minus 48 is 16. F of 2 comma 4 will be 4 minus 8 is negative 4, plus 16 is 12, minus 24 is negative 12. I'm doing all of this arithmetic on the fly, so I could be screwing it up. Oh well. You get the idea what's going on here. 16 minus 32 is negative 16, plus this will give you 16. What did I say? 16 minus 32. I think this ends up at 0. So what is our minimum? Minimum is f of 2, 4 at negative 12. Our maximum, we have that tie. Okay, so assuming I didn't mess up any of the calculations, that's how you do this.